And gentlemen, thank you very much for giving me a screen. My name is Gawel Solosky from Bengal University. My topic of today's lecture would be dark fermentation from gelatin. What is dark fermentation? Dark fermentation is a special case of anaerobic digestion, which stops in the acidogenesis stage. Dark fermentation has three, not four stages. Hydrolysis, two stages of hydrolysis, which makes makes a processing feed into simple organic matter, and acidogenesis, which is microbial conversion of this simple organic matter into acids and hydrogen. This is in case natural pathway, and condition of natural pathway. Because in natural pathway, the process of microbial digestion comes to pyruvate. Of course, there is in case of unmodified enzymatic case of cellulitic pathway, which breaks cellulose bonds into hydrogen and is more efficient than theoretical in butyric pathway, but still not very well confirmed. Therefore, the most regarding concerning to the pathway is this natural, which leads to the Gawel rule, which says that to Gibbs energy. So if process can stay, if Gibbs energy is negative, can occur. The most spontaneous is for butyric pathway, and less but more affordable for our processes because dark fermentation design focus on production of hydrogen. As production is pathway which leads to acetic acid, which because generates four molecules, and therefore the maximal yield of every feed is calculated assuming that we have only acetic pathway, which is not obtained in laboratory methods, but the optimal is to acetic pathway, which generates 33%. The optimal feed is simple feed. Thus, every laboratory initial stage of processing is starting from simple organic matter. I choose gelatin because gelatin is the form of powder collagen, and therefore collagen is simple case of protein. Therefore, we have protein that is not very well hydrolyzed, is not very bond in average. So we don't have simple like in case of glucose or glycerol because more normally the modeling fit is glucose concentration because by simple organic matter we omit hydrolysis uh, influence and measure and optimize only optimal case. In case of protein waste, the optimal case would be the forming of feed on the form of simple proteins like collagen, which is simple protein, quite simple, in compared to other. Therefore, I decided to check it for protein because according to literature, the only some in theory says that can be productive, and no data was about only protein substance, only ways which contain some fat, some sugar, some mixture, so not containing. The many glucose research was say using agar plates of nutrients, but data doesn't say about the data of prime test sample, which was only agar plates. Therefore, I decided something similar. Agar plates would be also gelatin, but I chose some collagen. But I, but I chose the pork gelatin as more suitable and containing one molecule something more hydrogen sulfide. Therefore, I can observe by with sulfide, more sulfide compound atoms. Therefore, I can observe hydrogen sulfide emission. Gelatin contains the known mass of sulfur and it is need to calculate. Therefore, I chose to observe and check if the hydrogen sulfide that I observed during every production of hydrogen, in case of sour cabbage and wheatstone and oxo, is coming from the feed or from the organic waste. Because this is the simple calculation, we check, and after some, we combine hydrogen production, even 40 milliliters of hydrogen per 1 gram uh, of gelatin, and some 5 grams of hydrogen sulfide. This is because that the hydrogen sulfide emission was was much higher than sulfide contained in the protein added to feed. Therefore, we get the information that it comes the hydrogen sulfide not only from feed but from organic waste. This shows the origin of hydrogen sulfide because we use the inner column stressed and stressing of inner column, so preparing to hydrogen production because this stops production methanogenesis process, keep the bacteria in sporage form, and then after this heat stress, up to the some generation where the inoculum stressing need to be repeated due to methane production occurring, the production of hydrogen occurs, and this occurs by parallel with digesting of bacterial rests from sporage form, forming hydrogen sulfide emission. Therefore, we get that these two processes are too close together and showing that the protein can be some source of hydrogen also, giving the source of next scientific research. Thank you very much for listening to me. And 4,005 some recommendation and and this shows that some interest. Now the production is I work with connection of the other works. After this case, I check with sour cabbage, and the observation that was on collagen was also confirmed on sour cabbage. As a result was the publication that was published earlier in biomass. So in biomass was publication of sour cabbage by analysis of biogas component, because during hydrogen the anaerobic digestion of sour cabbage in microreation of conditions, because in this case I measure this was research was done earlier, but just microbial production of pork gelatin allows me to understand what happens in sour cabbage. Because during production during digestion of sour cabbage, because in compared to these two research in an article of so sour cabbage, I used inoculum unstressed and stressed, while in pork gelatin I use only inoculum stressed. This is because earlier I showed that in some the production of
Please
hydrogen.
start, Dr. Ramzan.
Thank you. Thank you very much.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن